for you guys so that you can have something to study from. This is going to be my explanation of 7.1 and my explanation of 7.2. Again, I'm pretty sure I know exactly what questions you're asking or going to ask in class, so I'm going to try to address all of those questions here. Your first question most likely is 7.1. How do I even start the problem? In any math class, if you don't know the previous things that you have learned, you're going to have a very hard time trying to learn something new. So that's a problem, and it takes work. You have to know things from the past that you have learned in math. For example, difference of squares. That is something that you have to see. You have to get good at it. You have to get used to it. Now, you learned difference of squares back in algebra, and it's been 2 years, and hopefully you have continuously, been reminded of this idea of difference of squares. Sometimes you have to look at the identities, and so in some cases, you might have to go back to this particular page here, and you might have to look up these identities that we have. Let me see if this will actually reload for me here. There we go. We might have to, you should have these identities written down somewhere. These are identities that you should be able to twist and turn however, whatever is needed. For example, you need to know and recognize that the cosine squared of theta is equal to 1 minus sine squared of theta, or sine squared theta is equal to 1 minus cosine squared theta, or that cotangent squared theta is equal to cosecant squared theta minus 1, and so on and so on. You do that in physics. You take a formula and you twist it all around to see what other formulas you can get from it. And you take these even-odd identities. So if you've got a negative angle, you use an even-odd identity so that you can get the angle to be, in fact, positive. You'll notice that all of these angles, now theta angles, are in a positive, and it's either going to be the entirety of the answer is going to be negative or the entirety of the answer is going to be positive. You use that in the off chance that, you need to resolve those even-odd identities. If you have a negative angle, you have to resolve that. That is one thing you have to do. You can't just work with a negative angle. You've got to resolve that so that it's a positive angle. And then the same thing down here with these reciprocal identities. You need to know them. You need to know that the cosecant of theta is 1 over sine theta. We need to know that. And same thing with quotient identities. You need to know that tan theta is sine theta over cosine theta, and cotangent theta is cosine theta over sine theta. We need to know those things. And if you don't know them, which is fine, you have them written down and you at least recognize that they exist. So going back to this problem, you are asked to verify that this identity is in fact true. And this did come from a ChatGPT question, and ChatGPT has stated that this is a typical pre-calculus test question. Well, guess what? This kind of a question, I think, is on my more medium scale to harder scale than I think I would probably ask. I would ask questions on a quiz that were probably a little bit more on the easier to medium scale. So a lot of the questions that are going to show up on the quiz are going to be identities that you'll easily be able to, adjust, change, use, apply, and then the answer should come pretty quick. These kind of questions I might ask on a chapter test. So what do? Well, we look at things. We look at what we can do. I look at the fact that, maybe I could split 1 minus cosine x into 1 divided by sine x minus cosine x over sine x. I suppose I could get somewhere with that, but I just don't necessarily see how I'm going to get anywhere with that. Another thing that I could do is, again, I recognize in algebra that what I am looking at is a ratio. It is a proportion. It is something that I can actually use a few properties with, which is cross multiplication that I can use. And if I were to cross multiply, what would happen? Well, I would get sine squared x is equal to 1 minus cosine x times 1 plus cosine x. Well, that's a difference of squares, and I would like to work with that. So I am going to cross multiply this just to see where this goes. So that's going to be sine x squared, and I'm just going to write this out so that you see it, 1 plus cosine x, and I'm going to use a difference of squares for that. So let me just rewrite this, and that's going to be 1 minus cosine squared x. And I recognize that 1 minus cosine squared x is in fact sine squared x, because I told you previously that you also need to recognize that when you see something like sine squared x plus cosine squared x equals 1, that this is also sine squared x is equal to 1 minus cosine squared x, or this is cosine squared x is equal to 1 minus sine squared x. Well, I see 1 minus cosine squared x here, and that tells me that this is sine squared x. I know that because if I were to subtract cosine squared x from both sides, I would get sine squared x is equal to 1 minus cosine squared x. And I know that this equals this, so I can replace this with this, and I have shown that these identities are in fact equal because this is simply just 1 equals a 1 ratio. So this is in fact true. Now, how do you show this on a test? Number one, you are going to have to show me that you have done this, and you are going to have to show me that you have done this, and then this. Now, how do you know to do that? Well, how else are you going to show this to me? How else are you going to show me that these two things are in fact true? You're just going to say they're true? That doesn't cut it. You have got to show me what you have done to get to this point. And quite honestly, there is nothing that you can do to get to this point without showing work. There's no way you can get to this point without showing me what you've done. It's impossible. Because if you come from here and you go right to here, that means you're just guessing. You have to literally show this to me. You would have done this in your head. Write it down. Write everything down that you are doing to get to this point. That is called a math proof, and you cannot not exclude any of these lines. You have to show. This is exactly what I intend to see. And it's easy. It's not hard. You can write these 3 lines because these are properties of which you have already learned. This is a ratio cross multiplication property. This is a difference of squares property. And this is therefore a Pythagorean identity property. You can name each one that you've done. We did this in algebra. When you're looking at a PEDMOS question or something like that, and you're saying, I'm going to apply a distribution property to it. Then I'm going to apply a subtraction from both sides property to it. I'm going to apply an inverse property to it. You've done all of that. You have to write all of that down. All of it. If you don't, you risk losing points. Write it all down. And every single step of the way, you have a plan, a property that you are using. This is a cross multiplication property of proportion to ratios. This is a a difference of squares property. And this is a Pythagorean identity property. It's that simple. It's really not. The hardest part about this is going in a direction. What direction shall I go? If it's the right direction, then it will solve quickly. If it's the wrong direction, it's going to be hard. You're going to find that things are getting a little hard. So maybe you might want to go back and try something new and see if it's a little bit easier. It should not be like, you should not have to use a property that is incredibly complicated. Difference of squares, cross multiplication, Pythagorean identity, those are all easy properties. Let's try another one just to see how we can do with another one. It's the same thing. Let's do this one, sine x over cosine x. That's going to be plus cosine x sine x. And that is equal to 1 over sine x cosine x. Well, there's one thing that I see immediately, and that on this side I see a denominator with sine x cosine x, and on this side I see a denominator that's got a cosine x, and I see a denominator with a sine x. And how do I get from two fractions that have different denominators to another fraction when I were to apply them that has both of those denominators added together? I have obviously then tried to add these together. I've obviously tried to do that because the end result is the two denominators together. I have obviously tried to do that. Again, we have to be familiar with our previous knowledge of algebra. So then what do? How do I then add these two together? Well, I can't add them because cosine x and sine x are different denominators. I need to get it so that these are the same denominators. It's like adding 1/2 plus 1/3. I just can't do that. I've got to change the denominators 2 and 3 into something that are the same so that I can add them together properly. So what do? Well, I could, see if I can get my pen to work here. I could take this and multiply it by sine squared x over sine squared x. That's just multiplying this by 1. That'll work, because if I multiply anything by 1, I get it back. And over here, I could multiply, and it's going to be a little tight, but I'm going to try to do my best here. I can multiply this by, it would have to be cosine x squared over cosine squared x. Okay. Again, I'm multiplying this by 1. I can do that. And so what do I get? Not sine squared x. It would just be sine x. Sine and cosine x over here. Because what I'm trying to get is I'm just trying to get sine x, cosine x for my denominator. So now what do I get when I am done? Well, if I multiply these two together, I get sine squared x. If I multiply sine x by cosine x, I get sine x times cosine x. If I multiply these two into each other, I get cosine x, cosine squared x. And then that's going to be sine x times cosine x. And that's equal to this. This denominator and this denominator are the same. So I can rewrite this as sine squared x plus cosine squared x. And that's all divided by sine x times cosine x. And this is equal to 1 because the Pythagorean identity says this is equal to 1. So that's now 1 over sine x times cosine x. And that is, in fact, what we were trying to prove. Okay. This particular question is testing your ability of fractions. And I said this when people were in algebra. If you don't know fractions, you are way behind. If you don't know fractions now, you are further behind than just way behind. You are detrimentally behind when it comes to fractions. At this point, you need to be masters of fractions. In algebra, you just needed to be familiar with them. Now you guys need to be masters at them. You have to be masters at fractions. If you are not, then you better start studying them. Get used to them. You need to be able to do this stuff and see this stuff in your sleep, because fractions are always going to be a part of math. They are a huge part of physics. You've got to get good at fractions. At this point, you can't afford not to be good at them anymore. They're going to cause you to lose points in tests. I think I'm done with this. I don't think I need to go in any further. I don't want to make this video too long, but that is literally all you're going to be doing with identities. You're just going to be proving to me that one side of the equation is equal to another side of the equation, and you're going to work on it until they do, and you're going to show me your proof 100%. The other part that's on this quiz is the sum and difference formulas. So let's just take the same example that I did before. Cosine of 7 pi over 12. Now we can let's grab that one unit circle. Let's have OpenStax grab that for us. This unit circle right here. Again, I show this to you on your notes. You have to know what this is. You don't have to have it memorized. You have to know what this is. You have to know what it means to be square root of 3 over 2, 1/2 when it comes to being at this point in the unit circle. You have to know what that means. You have to know what it means that you are square root of 2 over 2 and square root of 2 over 2 at this point in the unit circle. Okay, what it means is that at this point in my unit circle, this whole circle is 1 unit away. At this point of my unit circle, which is degree, this degree here is pi over 6. If I were to draw a line to this point right here and draw another line down here so that there's a right triangle that can be formed, this line up to that line that I drew, okay, that is my cosine line. Okay, that's my cosine line. The length of this line is square root of 3 over 2. The length of this line from here up to here is 1/2. So this point right here is at the square root of 3 over 2 for x and 1/2 for y. That's what this unit circle means. So if I asked you what the cosine of pi over 6 is, you would say square root of 3 over 2. If I asked you what the sine of 60 degrees was, you would say square root of 3 over 2. If I asked you for the cosine of 90, you would say 0. If I asked you for the cosine of 210, you would say negative square root of 3 over 2. Would you have it memorized? No, you don't need it memorized. You know that by looking at 7 pi over 6 that its reference angle is pi over 6. So you know that the cosine is square root of 3 over 2, but your question here is, where is my original point? What quadrant is my original point? My reference angle tells me it's square root of 3 over 2, but where is the point? The point is here in quadrant 3, which means it's not square root of 3 over 2. It's negative square root of 3 over 2. And if you notice every single thing here, this is the same as this. 120 degrees is the exact same thing as this, except the x value is negative. Over here, this 210 is exactly the same as this 30, as this 240 is exactly the same as this 60, because the reference angle of 210 is 30, the reference angle of 240 is 60. But you'll notice that, but you'll notice that over here at 210, it's square root of 3 over, it's not square root of 3 over 2, it's negative square root of 3 over 2. And it's not 1/2 for sine, it is negative 1/2 for sine because I'm in the third quadrant. I'm grabbing the reference angle. They're the same answers, but it's going to be a different sign because of what quadrant I'm in. The reference angles will give me these answers right here. The actual point where I'm at tells me what quadrant I'm in. That gives me whether or not it's a negative or a positive for any of these three. These values are always going to be the same throughout this table. You just have to ask, am I negative? Am I positive? That's what this unit circle means, and that's what you have to know going into this, because now you're going to be asked the following. What is the cosine of 7 pi over 12? Do you see 7 pi over 12 here? No, you don't. There is no 7 pi over 12 radian on this unit circle. But I'm asking you to give me an exact answer. So how do you do it? The only way that you can do this, that we now know, is by using what's called a sum or difference formula. And so what we're going to need to do is we're going to need to come up with some angle alpha and some angle beta that when either added together or subtracted, it will equal 7 pi over 12. So if I were to take pi over 12 and add that to 6 pi over 12, well, that's 7 pi over 12. This is my alpha, this is my beta. My alpha is pi over 12, my beta is 6 pi over 12. Well, this reduces to pi over 2. I have a value pi over 2 that I can use. It's right here. But I don't have a value pi over 12. It doesn't exist on this chart. So I can't use this. This won't work for me. Whoops, this won't work for me. Can't use it. What about, well, let's try another one. Let's do 2 pi over 12 plus 5 pi over 12. I can use this one. This will work. But this one won't. This doesn't reduce, and there's no 5 pi over 12. Can't use that one. Well, what about 3 pi over 12 plus 4 pi over 12? Again, that is equal to 7 pi over 12. That's what I'm trying to find. I'm just splitting this up like I would if I was trying to factor something. Well, this reduces to pi over 4. This reduces to pi over 3. They're both on the unit circle. I can, in fact, go ahead and use that. So I am now going to erase all of this stuff because I don't need it anymore. I have already found what I'm looking for. I have found my alpha, which is pi over 4, and I have found my beta, which is pi over 3. And if I add them together, so cosine of pi over 4 plus pi over 3 is going to give me the same result as cosine 7 pi over 12, because pi over 4 plus pi over 3 is equal to 7 pi over 12. And again, it's all about fractions. If you can't see it, then you don't know your fractions. You should know this. This should make sense. Okay, that part should be simple. Now we need to know what to do with this. And what we do with this is called a cosine sum and difference formula. And it is written in your notes. The formula for this can be written as the cosine of alpha plus the cosine plus beta. And this can be written in the following way. Cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. If I'm adding two angles together, this is my formula. So what is the cosine of alpha? Well, the cosine of alpha is whatever my alpha value is. What is my alpha value? My alpha value is right here. It's pi over 4. So cosine of alpha is cosine of pi over 4. What is my cosine beta value? Well, my beta value is right here. It's pi over 3, right here. So I'm literally going to be taking the cosine of pi over 3. I'm using this formula. I'm then going to take the sine of alpha, which is the sine of pi over 4, and I'm going to be multiplying that to the sine of beta, which is pi over 3. This formula can be expanded into this formula, which is now, according to this problem, expanded into this statement. And I'm now going to use the unit circle to tell me some of my values. So the cosine of pi over 4, well, what is it? Well, that's the square root of 2 over 2. What is the cosine of pi over 3? Well, that is 1/2. What is the sine of pi over 4? Well, that is the square root of 2 over 2. And what is the sine of pi over 3? Well, that is the square root of 3 over 2. And then I simplify. The square root of 2 times 1 is the square root of 2. 2 times 2 is 4. The square root of 2 times the square root of 3 is the square root of 6. And that is 2 times 2 is also times 4. And so now I have my answer. The cosine of 7 pi over 12 is equal to the square root of 2 minus the square root of 6 over 4. This chapter is not hard. This chapter is just plug and play. That is literally all it is. You are going to probably need to write down these formulas. Okay, you're going to probably need to write down the formula for cosine plus alpha plus beta. You're going to need to write down the formula for cosine alpha minus beta. So that if you are going to take a difference of angles, you would use that formula. If you're going to take the sum of angles, you would use this formula. How do you know which formula to use? Because you are being told that you need to find the cosine of a particular angle. You're going to take that angle, you're going to split it into an alpha plus beta, and you're going to use the appropriate formula. Same thing with sine. There are two formulas here, sine alpha plus beta, sine alpha minus beta. Make sure you are using the proper formula, okay? If you use the wrong one, it's going to be the wrong answer. How do you know which formula to use? You're being asked the cosine of a particular angle, and you're going to split that angle up into a alpha plus beta. You're being asked to find the sine of a particular variable. So, for example, what if I were to say, same idea here. Same idea here. Instead of asking, though, for the cosine of 7 pi over 12, I'm asking you for the value of 7 pi over 12 for sine. Well, again, we've already done half of the work here. We already know that I'm looking for my alpha plus beta is pi over 3 over plus pi over 4, except I'm looking for the sine of 7 pi over 12. So I'm going to use the sum formula for sine, which is different from the one that we just did. The sum formula for sine is equal to sine alpha times cosine beta. plus cosine alpha sine beta. What is sine alpha? What is alpha in this case? Alpha is pi over 3. Okay, so sine of pi over 3 times cosine beta. Beta is pi over 4. Cosine alpha is pi over 3. And sine beta is sine of pi over 4. What is sine of pi over 3? I believe that is 1/2. No, it's square root of 3 over 2. Sorry. Square root of 3 over 2. Cosine of 1 pi over 4 is square root of 2 over 2. Cosine of pi over 3, that's 1/2. And the sine of pi over 4 is the square root of 2 over 2. Make sure that, again, I've got that right. The sine of pi over 3 is, in fact, square root of 3 over 2, and the cosine of pi over 3 is, in fact, 1/2. So I simplify. I have the square root of 6 over 4. That should be a plus, by the way. Plus the square root of 2 over 4. And that's now going to give me the answer that I'm seeking. So that's the square root of 6 plus the square root of 2 over 4. This is equal to this. And you'll recognize that cosine 7 pi over 12 was a different answer. Because, again, they should, unless it's that 45, pi over 4 or whatever those are always going to be the same. But this one has, obviously, a different answer from cosine. Different formula. In this case, I'm asking for the sine value of 7 pi over 12. I find it using the same alpha and beta that I use for cosine because they, when added together, will equal 7 pi over 12. There is another one here. Tangent. I didn't mean to hit that button. We'll stop this before it loads. There's the tangent formulas. Tangent of two angles, alpha plus beta. This is the formula that you will use. The tangent of a minus beta. This is the formula that you will use. You're probably asking, well, what about cosecant, secant, and cotangent? Isn't that just the reciprocal? So if I'm going to be finding a cosecant, why don't I just do 1 over sine, and then I can use the sine of the sum and difference formula for that. It's complicated because it's now a fraction, but it is what it is. If I know these three, then I'm good to go. And if you want to, you can come up with your own identity for cosecant, secant, and cotangent. I'm pretty sure one exists, and I'm pretty sure you can find it. If you were to, use this proof that's right here, you can always use this proof to figure out the identities for sum and difference functions for the other three. But we're not going to worry too much about that. So again, if you're going to be finding the exact value of tan pi over 6 plus pi over 4, remember I could be asking that question about what in a single angle, and you would have to split that angle. So what is this actually asking? Well, that's pi over 6 plus pi over 4. If I were to add those two together, that's pi over 6 plus pi over 4. Multiply this by 2, that's 2 pi over 12. Multiply this by 3, that's 3 pi over 12. That is 5 pi over 12. This problem right here is asking what the tan of 5 pi over 12 is. We don't know what that is. That's not on my unit circle. But if I split 5 pi over 12 into pi plus 6 plus pi over 4, or pi over 6 plus pi over 4, I can now find the value using this formula. It's just like taking the number 10 and figuring out how many different ways I can add them together. 5 plus 8, or 5 plus 5, 2 plus 8. You're just taking a value, a radian that you can't find in the unit circle. You're going to use two values that you can find in a unit circle, and when added together equal this value that we're trying to find. Cofunctions. If you've noticed, cofunctions are just a difference formula. It's the cosine of pi over 2 minus theta. That's a difference formula. I could use the difference formula for cosine in both of those. But what's really interesting is that in some cases, when you have a particular value for alpha and a particular value for beta, I could actually use what's known as a cofunction identity and rewrite it to actually mean something else. Okay? So you'll notice that, we can use sum and distance formulas for cosine. And if you were to apply that to cosine of pi over 2 minus theta, notice that it's cosine of pi over 2 times the cosine of theta plus the sine of pi over 2 times the sine of theta. You'll notice that cosine of pi over 2 is just 0. Well, then 0 times cosine theta is 0. We have also been told that the sine of pi over 2 on my unit circle is 1. And so 1 times the sine of theta is just the sine of theta. So as you can see here, this proves that this cosine function, or this cofunction identity, there we go. If this cofunction identity here, this proof, shows you that you could just rewrite it as sine theta. And so if I were to give you a cofunction identity, you would be able to do that. Write sine of pi over 7 in terms of its cofunction. It's the same up here to write tan of pi over 9 in terms of its cofunction. The cofunction of tan is the cotangent of pi over 2 minus theta. We are using pi over 9 as my angle, so I would rewrite the tan of pi over 9 as its cofunction, cotangent of pi over 2 minus pi over 9. I'm looking for this angle, and we know that the cofunction of any angle we can represent by just using the cofunction rules. We know that the cofunction of tan right here is cotangent pi over 2 minus theta. So if I'm asked to find the cofunction of, I'm supposed to write tan of pi over 9 in terms of its cofunction. Well, the tan of theta is equal to the cotangent of pi over 2 minus theta. Theta is pi over 9. So I replace pi over 9 in theta, and I now have an answer of what tan pi over 9 is in terms of its cofunction. If I wanted to get this angle, if I wanted to figure out what the cotangent of 7 pi over 18 is, it's going to be equal to the tangent of pi over 9. They're both going to be the same. Why would we do that? It might be easier if I have a cotangent of 7 pi over 18. Well, I don't know any sine or cosine function unless I were to figure it out like I told you. But I can use its cofunction, get it into tan, and then I can use the tangent formulas for sum and difference formulas in order to get my answer. So I can use cofunctions to switch back and forth. That's another possibility. So the same thing with sine of 7 pi over 7. Well, what is sine's cofunction? Its cofunction is the cosine of pi over 2 minus theta. So what would we write? Well, what is the theta? Pi over 7. So we would write sine of pi over 7 is equal to the cosine of pi over 2 minus pi over 7. Well, you would write down what pi over 2 minus pi over 7 is, and whatever that result is, that angle, when I take its cosine, is equal to the sine of pi over 7. That's what a cofunction identity is. I can take an angle that I know, and I could use a cofunction to represent it in a different way. That's all it really is doing. Okay, that's all a cofunction really is. Beyond that, the other thing that I might ask you on a quiz is the something like this: inverse angles. Or I'm sorry, inverse functions. An inverse function, if I give a value like inverse of cosine of 0. Remember, I am, for my function, this value here, that is not an angle. That is a value. The output of an inverse function is the angle, okay? So whatever this is, it's going to come out as an angle. And whatever this is, it's going to come out as an angle. So we look this up. What is the angle that would give me, what angle for cosine is going to give me the answer of 0? Well, pi over 2. So if I come down here and I have this particular question that's being asked, what is the inverse cosine of 0? That's pi over 2. What is the inverse cosine of 1/2? That's pi over 3. Oops. Okay. So this is basically saying the sine of pi over 2 minus pi over 3. It is a difference formula for sine, and I would use the difference formula to solve. That's it. That's all we have to do for those kind of problems too. Again, nothing major. 7-2 is leagues easier than 7-1. 7-1 is very theoretical. You got to kind of feel your way through it. 7-2 is entirely technical. There is a method, and you use that method and you get the answer. But you have to know what we did on chapter 6. You got to know what we did in chapter 5. And you got to know your algebra. Okay, we can do this. So hopefully this has helped you, and hopefully this has answered many questions. If not, come see me in the morning on Monday. I will be there, and we'll see where you guys are at.